Given that y equals a to the power x, where a is a positive constant, show that dy by dx is equal to a to the power x ln a. Well, I'm going to start by taking logarithms of both sides. So I'll get ln y is equal to ln a to the power x. I'm now going to use the law of logarithms to help me to bring that power of x down to the front. And now I'm going to differentiate both sides implicitly. So differentiating ln y with respect to x means I'm going to differentiate it with respect to y first to get 1 over y, and then multiply it by dy by dx. Now differentiating x ln a with respect to x, well that's just x times ln a. Ln a is a number, so a number times x will differentiate to be that number, so just ln a. 2x differentiates to be 2, 3x differentiates to be 3, pi x differentiates to be pi, ln a x differentiates to be ln a. I'm now going to multiply both sides by the y to make dy by dx the subject. And remember what the y was in the first place. Let's get this only in terms of x. So I'm going to swap the y back. Remember, it is a to the power x. And this is the result that we needed to prove. So that's part A of this question done, or part I done, rather. Next, we're told that x is 2 tan y, where y is between minus pi over 2 and pi over 2. And we need to show that dy by dx is equal to k over 4 plus x squared. So I'm going to start off by differentiating both sides here with respect to y. So I will get dx by dy, and differentiating 2 tan y with respect to y, I'll get 2 sec squared y. Doing the reciprocal now, I'll get dy by dx is equal to 1 over 2 sec squared y. Now I need to remember the identity that tan squared y plus 1 is equal to sec squared y. So I can replace this sec squared here with tan squared y plus 1. Expanding those brackets, now I need to get this in terms of x, not in terms of y. And I do know that tan y, just rearranging this original equation, tan y is equal to x over 2. So if I substitute this x over 2 here instead of the tan y, expanding these brackets, I'll get x squared over 4. Which, when that gets times by the 2 at the front here, the 2 times the x squared over 4 will be x squared over 2. And now, just to tidy this up, I'm going to times the top and the bottom of this fraction by 2 to get rid of that nested fraction, and I'll get 2 over x squared plus 4. That is my expression for dy by dx. And that now matches up with what we needed to show, where k is 2.